ARP, which stands for Address Resolution Protocol. Its job is to resolve IP addresses to MAC addresses. And today I will help you understand the magic behind this process and what it actually means. So welcome to the Networking Fundamental series, in which we talk about essential networking topics. Okay, so let's break down what I said in the beginning. ARP is used to map the IP addresses to MAC addresses. Now, to understand that, we first need to know what these two addresses actually are. IP address is a logical address. It can change depending on the network. And the MAC address is a physical address. It is burnt into the network interface card of a device. We could say that MAC address is like a street address of a house. It usually never changes. The house should stay forever and it will tell you the physical location. Therefore, MAC address is a physical address. And IP address is an address of a person living in that house. It can change, people can move out, but the house will remain in that same place. So IP address is a logical address, and MAC address is a physical address. And now when we want to send a letter to somebody, a letter is our unit of data. We know this person's name, but we don't know where they live. We still need their physical address, and that's exactly why we need ARP. We need to map the logical addresses, in our example person's name, to the physical address, in our example the house. Okay, so now let's take a look at our very simple, very small lab environment in Cisco Packet Tracer. So what do we have in here? We have a switch that is connecting two computers, computer A and computer B. And now if computer A wants to communicate with computer B, it needs to know its IP address. I already wrote the IP addresses in here, but we can also check that in the terminal. So we can go in here and simply type in ipconfig. And here we can see that the IP address of this computer is 10.0.0.1 and the IP of this computer is 10.0.0.2. You can see it here. Okay, so now the first thing that computer A will do when trying to communicate with computer B is check in if it already knows its MAC address. So remember, when we want to send a letter to someone, we need to know this person's name. And in our case, the name of this computer is 10.0.0.2. But we also need its location, its physical MAC address. So computer A, first thing it will do will be check in if it already learns the MAC address of computer B. And it will check it in ARP cache, also known as ARP table. This is a table of IP addresses mapped to MAC addresses. So we can also check that in the terminal by typing in ARP-A. And at the moment, as you can see, there are no ARP entries found. And this is because there hasn't been any communication yet between these two devices. Okay, so if the ARP cache is empty and computer A doesn't know the MAC address of computer B, it will send out a broadcast message to all other devices in the network asking who is 10.0.0.2. And right now we can actually add two more devices to the network, two more computers. So let's just do that very quickly so we can understand better how it works. So we have right now 4 computers connected to our switch. This is our small private network, and computer A is asking who has 10.0.0.2. Give me your MAC address, I need it. And then the computer that has the IP address of 10.0.0.2 will respond saying, I am 10.0.0.2. This is my MAC address. And now, after mapping the MAC address to IP address of computer B, these two can communicate. Okay, so let's look how it actually works. So we can try to communicate with computer B. So we will send a ping to 10.0.0.2. And now we can see that the ping is working. This is because these devices are physically connected. And now we can check the ARP cache one more time. And right now you can see that the MAC address of computer B has been learned into the ARP table. And the type of this is dynamic because it happened automatically in the background. However, we could also add this entry manually by typing in ARP-S, then giving the IP address and the MAC address, and the entry would be added statically. So to quickly summarize it, ARP will map IP addresses to MAC addresses, and it does that by sending an ARP request as a broadcast and then receiving an ARP reply. The results will be stored in the ARP cache, so the devices don't have to ask for it all the time. However, the ARP cache results are not permanent, they will be flushed out after some time, so the process has to be repeated. The ARP is also not perfect, it has its weaknesses and mainly it has no authentication. It will trust whoever responds first and it opened the door for man-in-the-middle attacks, like for example archive poisoning or ARP spoofing. And I will talk about it in more detail in one of the next videos.